So today what we're thinking about is uncertainty. And primarily we're going to be thinking about visualizing uncertainty, but then I've also got some resources for you about writing about uncertainty. And a lot of the material that I have here is just pointers to other YouTube videos if you want to learn more about this. One of the pointers, which I'll put in the Stat 336 Extras playlist, is a talk that I gave at OpenBizConf in 2016 called Do You Know Nothing When You See It? So I've got the link in the slides, and then it'll also be in that playlist. And in that talk, what I'm arguing is that statistics is trying to answer sort of like two general questions. One is this number different than zero? That's essentially hypothesis testing. And then the other one is, how sure am I about this number? Or what are some other reasonable values I could have observed? And I think in the video in 2016, I do a decent job of explaining that, but I've kind of refined that material. And I actually just uploaded a video for my intro class on YouTube. So I'm going to add that to the extras playlist for our class as well, in case you want to go back and look at some stuff about hypothesis testing and confidence intervals in a simulation scenario using Bootstrap or randomization. And then the other thing in the talk is I'm making the connection to the questions that we ask in visualization that are parallel to those statistical questions. So we might ask, is this visualization different than nothing? So our human brains are really good at finding patterns. If we look at something visually, that's why we see things in clouds and can sort of see faces in everyday household items. So if we make a plot, we can often tell ourselves a story about it, but it might just be the result of random chance. And so one of the techniques I talk about in that talk is the lineup protocol. And the lineup protocol is going to put your real plot, where you think there's a story, randomly in an array of 20 plots. And the other 19 plots are going to be some permutation of your data. So in this case, I have this ggplot. I'm looking at loan balance against income, and then I've colored the points by whether someone defaulted on the loan or not. And I think that you can pretty easily pull out which is the real data. It's number 14. So that looks pretty different from the other plots here. And we use 20 plots because that is going to have a 1 out of 20 chance if you're just guessing randomly, and that's 0.05, which corresponds with the alpha level we most commonly use when we're doing hypothesis testing in sort of standard numerical statistics. So this lineup protocol, I think, is a really nice tool to have in your toolbox to make sure that your visualization is different than sort of a nothing visualization. But then I think the larger question, if you're going to publish a graphic and you're pretty sure that it shows something, you want to convey to your readers how sure you are about the story that you see. So that's going to require some more uncertainty visualization. And the kind of standard solution, like from Excel, would be to add error bars. So in this plot, the red dots are the means, and then I've got error bars going out, I think, to 1 standard deviation. And then I can see where there's more uncertainty. And there are sort of variations on this that we could do, right? We could use a box plot, which I know we've talked about before. We could use the interquartile plot, Tufte's version, where we're going to be maximizing our data inc ratio. We could use a violin plot, and then there's all these other variations where we could see something about the distribution of our data rather than just the mean, and maybe more than just the mean and the standard deviation. But the problem is that visualization researchers have found that error bars are not very easy for humans to interpret. So over here on the left, this is probably the most common way that you see error bars with box plots, is you've got, the top of the box is here, and then we're putting the error bar sort of over the edge. So this is the bottom, and this is the top of the sort of uncertainty that we're trying to quantify. But the problem is that most people, when they're looking at this, the bottom of the bar gets absorbed into the bar. It doesn't stand out visually. And so then the only uncertainty that people are really seeing is the part that sticks out over the top. So there are other methods. Maybe you want to use a box plot instead of bar plots, and then the middle of the line, that's the top of the bar, and then it's easier to see the whole set of variability. There's also approaches where you make it maybe darker in the middle and then lighter as it goes out and is less likely. And again, you could use violin plots. So those are better options than just using standard error bars. The other thing that you can do is you can add animations. So here I've got some animations of box plots. The box plots are draws from populations, and then I can see how the box plot itself changes from draw to draw. So I would suggest focusing especially on the lower two plots because the boxes are leaving behind a little trace, and I'm going to play the animation. So you can see that the boxes jump around and then they leave some trace of where they've been before. So you can really sort of experience the uncertainty by taking multiple draws from your population. There's a researcher in this space who I really respect, Jessica Hullman. She also gave a talk at OpenVisConf in 2016, and her talk was called The Visual Uncertainty Experience, and I put that in the playlist as well. And her work has been a lot about these things called hypothetical outcome plots, or HOPs. And hypothetical outcome plots are animations that let you see different possibilities as frames of the animation, rather than looking at all the possibilities at once. So for example, we could have seen all the possibilities at once using error bars. We could have seen all the possibilities at once using violin plots. But she is suggesting we use hypothetical outcome plots, which are animations, and she's shown a few frames here. And one of the things that's so great about hypothetical outcome plots is that they can show things like correlation between variables. So if you have variables that are uncorrelated, here we've seen a bunch of frames from our animation. So in the first frame, we've got A much lower than B. In the second frame, we've got A a little bit higher than B. In the third frame, B a little higher than A, and the whole thing moved up, right? So we can sort of see the variability, and they just kind of move around willy-nilly. But if we had two variables that were strongly correlated, like in figure 3, then the first frame we see that A and B are sort of low down here, but B is higher. Now A and B are a little bit higher, B is still higher. Now they're closer together, but B is still a little higher. So most of the time we're going to be able to see that in many scenarios, B is higher than A. And so it's going to show us something about that relationship that would have been invisible if we'd looked at the static plot. So I think I have an animation here. So again, I've got those same plots along the bottom of the screen, and then I've got an animation that I'm going to play at the top. And this is the example with the correlated variables. You can see that almost all the time B is higher than A. Sometimes something else happens, but most of the time they're sort of moving together in tandem. And again, this is giving me a sense of all the different possibilities, like different draws that we could have taken from the population, and letting me see them as frames in an animation. So we've got some ideas for one variable. So if we're looking at box plots or bar charts, we could do those sort of hypothetical outcome plots. It's more challenging when you have a relationship between like two quantitative variables. You have a scatter plot, but there are these bivariate extensions of the box plot. So making like a bag plot where you're showing the region where most of the data is, and then shading as you move out. And then there are some approaches to show uncertainty in spatial visualizations. So in this example, we've got 3 visualizations, one that prioritizes terrain, one that prioritizes the data, and one that prioritizes the uncertainty. I think it's really hard in a spatial scenario to show 2 variables, and so I'm not sure if this uncertainty visualization is really that effective, but people are thinking about these sorts of things. So all that material was really about visualizing uncertainty, but we can also write about uncertainty. And so for class, I've asked you to watch this video where we're going to let Amanda Cox tell us what to do. Amanda is now the editor of The Upshot at the New York Times, and she's an amazing data visualization and data journalist. And this is a keynote that she gave also at OpenVizConf the following year in 2017. And it's basically all about uncertainty. So she does talk a lot about visualizing uncertainty, but one thing that I think is really beautiful about this talk is she also talks about writing about uncertainty. So in this screenshot I'm showing, she's talking about some data about people's perceptions of probability based on words that are used. So that's the other piece of what I would like you to watch and get out of this class's focus on uncertainty.